Hi, I'm Randall.
And I'm Katterine behind the camera.
We're going to do a demonstration on the refraction and dispersion of light. First, a little theory. The speed of light in a material is less than the speed of light in a vacuum. The index of refraction, n, is equal to the speed of light in a vacuum over the speed of light in a medium, or n equals c over v. As light moves from one medium to another, the wavelength changes, but the frequency remains constant. Velocity is equal to frequency, which is constant, times lambda wavelength with changes. The velocity of the refracted beam is less than the velocity of the incident beam, so v2 is less than v1. The index of refraction, n, varies with the wavelength of the light passing through the prism. This phenomenon is called dispersion. Light of different wavelengths refracts at different angles when incident on a material. The index of refraction, n, decreases as the wavelength increases. Red light, for example, with a wavelength of about 400 nanometers, refracts less than violet light with a wavelength of about 700 nanometers. When a beam of white light is incident on a prism, the angle of deviation is contingent on the wavelength. The rays that emerge from the prism consist of the colors of the visible light spectrum. These 6 colors are red, orange, yellow, green, blue, and violet. Violet has a wavelength of about 700 nanometers, which is greater than that of blue, which is greater than that of green, followed by yellow, orange, and finally red at 400 nanometers. Each color possesses a discrete angle of deviation.
To illustrate that, here is our incident ray going into our prism through the first glass. This is our infracted ray, and this is our angle of deviation. This is our second glass. This is the second emerging ray, the second infracted ray. This is our angle of deviation.
We will demonstrate that the colors can be recombined with the second prism to form the original white light. So, okay, let's get set up.
These are our prisms, 2 identical prisms.
And I'm going to kill the lights. And it's showtime. Here we have the colors of a visible light spectrum.
And here,
and we're going to introduce a second prism.
Here comes our second prism, and it's gonna get the white light. It's just hard to do when there it is. There is our white light.
The colors have been recombined to form the original white light. Thank you.
Thank you.